the first session, the teaching section, I did record. If you go on your Blackboard account and you look at class recordings, in that section, you will see a video of each class. Um, I'm gonna have to mute everybody. Uh, Remember how to mute everybody. It doesn't. Okay, I've muted everybody, but you can unmute yourself anytime you want to open up you want to say something. I just think when there's outside noise, it's better just to have everybody muted. Um, so as I was saying, I did do a recording of the first class, and I will record each class, and I will post it in the recording section of our Blackboard account. I will try to include in the description exactly which topics are covered. So if, number one, if you miss a class, you're always able to go back and see the recording. It's not every single thing that was done in class, but it's all the main teaching will be there. So you'll be able to keep current with the work, even if you have an appointment or something else going on. And number two, sometimes you just want to review something that was done in class. You want to see it again. Again, you'll be able to see which topic um, you want to go over, and you can see that recording. They're all YouTubes, but they're YouTubes specifically of our class. It's not a YouTube of something else. In addition, if those of you who signed up for Delta Math and made and did the work on it, there is homework number one
Good morning.
on the Delta Math. You see that if you're having trouble with a problem, for each problem, there is actually a help video that shows you how to do the problem. Then if you do the problem and you submit your answer, it shows you exactly how it writes out how the answer is done. So it's not just a matter of doing homework for the sake of homework. It also will help you to review and be able to do examples. And if you don't know how to do example, you'll be able to see a exact sort of example like that done right there and then. You don't have to wait to get to class again to ask about it. Of course, anytime you're having trouble with doing a problem, it could be a specific problem, or it could be just a type of problem that you're having trouble with. I really would be very happy if you would bring it up in the next class, because generally, if you're having trouble with a type of problem, other people in the class are as well. And if you want me to review it, I will review it, as long as you've made an attempt to try it and you don't understand it. That's where I want to come in, and I want to help you with your understanding. In terms of the Delta Math, I would say over the course of the term, there might be something like 20 homeworks, 20 assignments. And let's say I give, I'm just making this up because I don't know exactly. Let's say I give 25 assignments on Delta Math. Then at the end of the term, when I go to give your homework mark, I'm going to look. That's really where I'm going to get your homework mark from the homework done on Delta Math. Yes, occasionally there'll be homework on Blackboard, but the main homework for the term is going to be on Delta Math. And I can see exactly what you did. I'll see how many problems you tried, how many problems you had to do before you got them right. Um, my feeling is if you made an attempt to do the homework, and I'll be able to see if you tried each of the types of problems, even if you didn't eventually get it right, as long as you made an attempt, that is considered doing homework and you get the point for the homework. So let's say I gave you 25 homeworks. I may assign a half a point for each homework, which means that if you did 20 homeworks, you would get the full 10 points. In other words, there will be a little leeway if there was a homework or two that you left out, you didn't get to it. I will excuse it and still be able to give you the full 10 points on your homework. There will also be some quizzes and tests on Delta Math as well, but when we get to that, then I'll describe how that will work. And now I had put this problem on the board and I saw a bunch of people did do it and they got the correct answer. I'll just go over it so that we can, and those people who did not get it right, let's see what you did wrong. And I really like this to be an interactive session. I know I have you muted now, but you're always able to unmute yourself to either ask a question, give an answer, make a comment. That's part of this. This is not just me talking. We're all working on this together. So let's look at this and just remind ourselves. I'm going to do this the way I always do it, which is by adding the opposite, or what we call the inverse, when we want to move something from one side to the other. I know some of you people, and we did an example like that, like to use the transposing method. If you're comfortable and you do things right using that transposing method, I have to tell you, when I first learned algebra when I was in high school, we used the transposing method, but it seems more recently the adding the inverse is the more accepted method. Again, both methods are totally correct, and whichever method you use, as long as you come up with the right answer, is fine. Don't forget that, especially if you're a person that has trouble with what we call sign numbers, you make mistakes with sign numbers, you can always use your calculator. Remember, that was one of the things I asked you to get a calculator. I know that over the weekend it might have been hard, especially with the weather. So I would certainly hope by the end of this week you do have a calculator. If you bought a calculator, I'll say this again, if you bought a calculator, you're not sure if it's exactly the type of calculator I really would like you to have, or if you have an old calculator and you're not sure if it's the right calculator, you can just show it to me. I'll try, if you hold it up, I'll probably be able to see it, and I'll be able to tell if it is an appropriate calculator. All scientific calculators will work, but the type I call the two-line calculator is much more user-friendly. You don't have to think too much as to how you're putting things in, and you can always see what you're putting things in. So I would say, especially for anybody who has problems with the sign numbers, make your calculator your best friend and use it as much as you can, and get used to using it now, because it definitely is going to be necessary later on in the term. And some people have a tendency to think that if they buy the calculator the day before the final exam, they'll be fine, but you really need to get used to using it. So make sure you have a calculator that you like, that you're used to using, and make sure it's with you every time you do homework and every time you're in class. That being said, let's deal with this. What we want to end up is having all the variable, all the x's on one side, and all the numbers on the other side. That's our first purpose. Now, the first thing we do is look if there's any parentheses. There aren't any. If there were parentheses, that would be our first step. We would remove the parentheses. The next step is to check each side before you start moving things. Just check each side. Is there anything that you could combine on these two sides? And of course, the 3x and this is a -5 are not like terms. They can't be combined. The 7x and the 19 are also not like terms. They cannot be combined. Once we're at that stage where we have no parentheses and everything combined, which means that you should at most have two terms on each side, you can then proceed with moving things from one side to the other. So the first thing is I want to get the numbers to the right side.
Does it matter what side you go to?
It doesn't make a difference.
So I could start with trying to isolate the 3x, or I could start with trying to isolate the 7x. Doesn't matter. It
does matter. That is totally in other words, moving things around, it doesn't matter which order you do it. I will, who was I talking to? Was that Emma?
Yes.
Okay, I recognize your voice from last time. And I'm happy that you're asking the questions and asking them as you see the questions, because that's where you're going to learn the best. You can interrupt me, I'm fine with it. I won't be fine when 20 people are interrupting me at one time, but one person at a time, that's fine. Okay, now, given that it doesn't matter which side you bring the x's to and which side you bring the numbers to, you will see that invariably I will bring the x's to the left side and I will bring the numbers to the right side. And I'll tell you, there are two reasons why I do it. Reason number one is because, to me, when you're answering a question and your answer is going to be x equals -6, for example, I like to be able to read it in the order it comes. X equals -6. Now, it's not wrong to say -6 equals x. That would be fine. There's nothing wrong with it, but to me, it makes more sense to me that the x should come first. That is a very minor reason for doing that. The more important reason for bringing the x's to the left side and the numbers to the right side is because the next topic that we are going to be studying after this is going to be inequalities. We're now dealing with things that are equal, equations. Now, then after that, we're going to talk about things that are not equal and how to solve those type of examples. And then it's absolutely essential that the x comes out on the left. So, and the working out of the inequality is so similar to the equation that I'd like to get used to doing it that way initially, so that when I get to the next step, it's just an automatic thing. Does that make sense to you, Emma? Okay. So I was at the point where I was going to bring this 5 to this side, right? Now, since this is a -5, I want to get rid of this -5. So I always do the opposite operation. I do the inverse operation. Since this has a minus, I'm going to put a plus. So I'm going to do a +5. Now, whenever I do something from one side of the equation to the other, in other words, there's this invisible line here. This is one side, this is the other side. Whenever I add something to one side, I've got to add it to the other side. So that when I get to the next step, I'll have 3x. I didn't do anything with the 3x, I'm just bringing it down. I have the -5 and the +5 that just cancel each other out. They add up to 0. So basically that's, I don't have to put it in. And that equals The 7x I haven't done anything with. And the 19 and the 5 is 24. Notice I added the 5 to the 19. I didn't add the 5 to the 7x because those are not the like terms. I have to always add the like terms. My next step is then, since I have now all the numbers on the right side, let's get all the x's, all the variables to the left side, which means I want to get rid of this 7x. Now it's understood when there's no sign in front of something, it's understood to be a plus. In other words, plus 2 and 2 mean the same thing. So 7x and plus 7x mean the same thing. So if I want to bring this to the other side, I have to use the opposite sign, that's inverse, which is minus 7x. But if I subtract 7x from the right side, I've got to do the same thing on the left side. Notice I put the negative 7x under the 3x because those are like terms. And now I combine 3x and minus 7x. Now, I really am expecting you to be able to do this. If you're having trouble, take your calculator and just do, you don't need the x parts. What you need is a number. You're just combining the coefficients. Do 3 minus 7 on your calculator. Of course, you're going to get negative 4x. Remember that because when you add sign numbers, if their signs are different, you're really subtracting them and taking the sign of the larger number. On the other side, the 7x and the negative 7x get canceled out because that's really 0. And so all we're left with is 24. And our final step in any equation is to divide by the coefficient of the x, which in this case is negative 4. I'm going to divide both sides by negative 4. Now, negative 4 divided by negative 4 obviously gives me 1. So this is going to be 1x, and 1x can be just written as x. Again, remember when there's no number in front of a variable, it really means that the coefficient is 1. The one, there's always an invisible 1 standing in front of this. So I could either write this as 1x or just plain x. On this side, I could do 24 divided by negative 4. Since I'm dividing a positive by a negative, I'm going to get a negative. And 24 divided by 4 is 6. So my final answer is negative 6. If this would have been an example on Delta Math, when you put in your answer, do not write x equals negative 6. Just put in the negative 6. And this is similar to some of those problems that I did give you for homework. Is everybody with me? Is there somebody who wants me to review this again? Are we okay with this?
Professor
Yes. Who's talking?
Kashira. It's Kashira.
Okay. Wait. Let me unpin myself so that I can see you. Okay. Speak loudly so I can see you. Kashir.
Okay. When you brought down the 3x equals 7x plus 24.
Right over here, right?
Yeah, what I did was I subtracted 3x on both sides. I thought the answer was going to be the same, but it's different because I got a positive number instead of a negative number.
Okay, so here's what you did wrong. When you bring this 3x to this side, what were you left with on the left side? What were you left with on the left side?
Nothing.
Yeah.
Okay,
Wait a second. Why am I running into problems? Speaker view. Just want to pin myself. Okay. I'm sorry, I'm just playing around with this. Okay. I was left, really, what you're being left with is nothing on this side, which really means zero on this side. And on this side, you were left with a 4x and a 24. Now, you can't be left with nothing on one side. The way you do this is you always want to end up having the x's on one side and the numbers on the other side. Don't take everything away from one side. Are you following what I'm saying?
Yeah. Yeah.
Now, if I'm going to go and take your example and show you how you could have handled that. Okay, you were over here. Now, everybody can listen to this, but this is not the way I would do the problem. You wanted to subtract 3x, right? Now, you always have to keep track. That's why I sort of, it might make sense just to make a line down where the equal sign is. What are you being left with on this side of the equal sign? Well, obviously nothing. We usually don't put in that 0 because there are other things. But if I can't just leave it blank, there's nothing there and I have to put a 0. This would give me, well, the 7x minus 3x would give me the 4x plus 24. And the problem here is now I have everything on one side and the 0 on the other side. You could either bring the x's to the, now you need to get the x's on one side and the numbers on the other side. If you wanted to, you could have subtracted 24 from both sides. Which would have, and 0 and negative 24 would have given you a negative 24 equals 4x, because now this cancels out. I don't have to put, this is a 0, but I don't have to put a 0 there because I have something else there. And now divide both sides by 4, and negative 24 divided by 4 is again negative 6. If you bring everything to one side of an equation, you will invariably, and leave the other side blank, which means you're just ignoring it, you probably will get the right number, but your sign will be wrong. Does that answer your question?
Yes, thank you.
Okay, okay. What I'm going to do is now, is there anybody else who wants to ask a question? Okay, so then I'm going to put another problem on the board, and I'm going to let you work on it. And then, while you're doing that, I want to take attendance. Okay, so I'm going to put the problem on the board. I'm going to do a problem that has a parenthesis. Okay. Let me. Can everybody read that? It says 4x minus 3, parentheses, 2x plus 1, close parentheses, equals 15. Okay, I'm going to take attendance now. Okay, so here we are. Whenever we have a equation that has a parentheses in it, our first step really is to get rid of that parentheses. We want to be able to have a clear picture without any extra things lying around there. And the parentheses are the first thing we want to get rid of. And what we do is we take the number that's in front of the parentheses, including the sign. In other words, there's a 3 here, but it's really a -3 because there's a negative in front of it, and distribute it. Multiply each term inside the parentheses by that number. So the 4x is not in the parentheses. I just bring it down. Notice I'm not multiplying by 4x minus 3. The only thing I multiply by is the number that's immediately in front of the parentheses. If I wanted to multiply the whole 4x minus 3 times the 2x plus 1, I would have had to have a parentheses around this as well. The 4x is not included in this multiplication. It's only the -3. -3 times 2x gives me -6x. And don't forget, we're distributing, so we have to multiply the -3 times 1 as well. And everything else stays the same. Our next step is to look at each side separately. We're not moving things yet. We're looking at each side separately and seeing if things could be combined on each side.
It's supposed to be 15 or 5.
Yeah, oh, I'm sorry. I see you. Somebody said I forgot the one. I didn't know what one I forgot. Thank you. That's why I need you here. I see on here I have a 4x minus 6x. Those are like terms. They're on the same side. I'm going to combine them. How much is 4x minus 6x? Well, 4 minus 6 is
-2.
So it's -2x. And I just bring down the -3 because that can't be combined, and that equals 15. And now we're at the point where we have all the x's actually happen to be on the left side. Let's get the numbers to the right side. So this -3 is what I want to get rid of. So I'm going to do +3. And of course, if I'm doing +3 to this side, I do +3 to the other side. Remember, when I'm adding something to one side, I have to add it to the other side. It has to be added to something on the other side of the equal sign. This stays the -2x. This -3 and +3 is 0. If there's nothing else left, I have to put the 0 in. But -2x plus 0 is just -2x, so I don't have to put that 0 in. I'm just making it looking for me. 15 plus 3 gives me 18. And now I'm at the point where I divide by the coefficient of the x. I'm dividing both sides by -2. And 18 divided by -2, the positive and the negative gives me a negative, and 18 divided by 2 is 9. And yes, most people did give me the answer -9, and that is the correct answer. Are we okay with this?
Yes.
Okay. So I want to do one other problem that before I go on to the next step. I think we're okay, but let's do one more problem just to make sure we're in. looking in the book to see if I can find something in the book. If not, I'm going to make one up myself. Again, the book is helpful as a reference guide. You do not need the book specifically to do problems from, because the homework and the exercises are either going to be on Blackboard or on Delta Math. So here's an example that I'd like you to do. Oh, maybe I can find one actually.
Professor, is there any way that you could show the book?
You want to see what the book looks like? Sure.
Yes, please. Okay, good. I got the right one.
Okay. Okay. Actually, this is a problem that is coming off of a final exam. So you'll see that these are the type of problems you might see on an exam. Here we are. Okay, so this has a lot of parentheses. It actually has 3 parentheses. And it's 2 parentheses, x minus 13, close parentheses, minus parentheses, 3x plus 6, close parentheses, equals 7, parentheses 4 minus x.
When it's just a negative sign, are we just adding the negative sign to what's happening in the parentheses?
Okay, so let's just discuss this, because that's why I was giving this problem. What happens if there's a minus in front of parentheses and there's no number there? Well, what happens? What is this here? What do we do? What does this x mean where there's no number in front of the x? What number is
Means
that?
1.
Yeah.
It's understood to be a 1. The same thing over here. This is understood to be a 1. If there's no number in front of that parentheses, you see, can you see? Because I tried it in red. I don't know if the red is coming out.
Yeah.
Yeah. Anytime you see a plain parentheses and no number directly in front of it, there's just a sign, it's understood as if there's a number 1 right in front of that parenthesis.
So it doesn't matter which parentheses we start from. It could be any of them.
Any of them, as long as you keep things in order. In other
Okay.
words, if you start with this one, then write it over here, but then you have to go this and put it in front. You can't mix the orders up.
Okay.
Eight.
So going on from what we know before, we see a bunch of parentheses, we want to remove parentheses. Now I'm just going to do it in the order I see it. In front of the first parentheses, I see a 2 and an x minus 13 inside the parentheses. I'm going to multiply everything. I'm going to distribute this 2 and multiply 2 times x, which would give me 2x. And 2 times negative 13, remember a positive times a negative gives me a negative
26.
26. Okay, we're now up to that next parentheses, which had just a negative. Now, remember that negative stands for a -1. I'm going to distribute -1 to each term in this parentheses.
Yeah.
So -1 times 3x is going to give me -3x. And -1 times 6 is going to give me -6. Be very careful with those signs. On the right-hand side, I have a 77 in front of a 4 minus x. So 7 times 4 is going to give me 28. And 7 times -x is going to give me
-7.
Okay, so we've accomplished step 1. We don't have any more parentheses. So our next step is to look at each side individually. I'm not up to moving things. I only up to moving things when I just have an x and a number on each side. I have too many things on this left-hand side. So we're going to have to combine, yes, Ashley, you're right. We're going to have to combine the like terms. We're not moving anything from one side to the other. So I'm not going to, like if I have a -26, I'm not going to do a -26 and a -20 and a +26 and a +26. I am only looking to combine the like terms. So what are my like terms?
2x and 3x and -26 and -6.
Right. So let's talk about the x's first.
I did it differently. I got the right answer, but I kind of skipped a step. I just like added I just added 26 and added 6 to the 28.
You can do it that way as well.
That's okay. Okay.
That's fine. As long as you remember what, sometimes I'm wondering if it makes sense to tell me what most people do as a mistake. Some people say do +26 over here and then over 26 to the 6 as well. You can't do that. If you're adding 26 on the left side, then you can add 26 to the left side as long as you go on the other side of the equal sign and add 26 over there. You can add one number to both, the same number to on the same side of the equation. It's always one number times one number. Now, I always like to combine the like terms. Now, what do I get when I add a 2x and a -3x?
-1.
Right, that's a -1x. I can either write it as -1x or just as plain -x. If you are, and either way is completely correct. It's perfectly okay to say -1x because that's what it is, but usually when there's a 1 in front of an x, we just write x. Then we can combine the -26 and the -6. They're on the same side, we can combine them. How much do we get when we have -26 minus 6? So we're combining two like terms, so 26 and 6 gives me 32. And when you're adding, you keep the common sign, so that becomes -32. Again, if you're making mistakes with your signs, just stick it into your calculator. Remember, there should be a plus minus button on your calculator. It's not the subtraction button. Usually it's towards the bottom of the calculator, and it might be with a negative on in a parenthesis, something like that. I would do -26 minus, now this is subtracting 6, and that'll give you -32. On the other side, we still have 28 minus 7x. So now we want to bring the x's over here to the left side. and we want to bring the numbers to the right side. So I'm first going to deal with the x's. It doesn't make a difference. You can deal with the numbers first or the variables first. If I deal with the x's, I want to get rid of this 7x. It's a negative 7x, so I'm going to do plus 7x. And therefore I have to do plus 7x. And of course I do it under the x because that's the like term. Negative x, which is a negative 1x plus 7. Well, negative 1 plus 7 is 6. So this gives us 6x. Just bring down the rest of it. Negative 32. This gets equals 28. Add 32 to both sides so that you get the x's alone. So now I have 6x over here. This is gone. 28 and 32 is 60. And if I divide by 6 to get my x, I get my answer, x equals 10. And I saw most people did get that answer. Perfect. Everybody okay with this now? Getting it? Okay.
Yes.
All right. Now, next step, I'm trying to see what we should be going and trying some examples with fractions. But I know most people don't like fractions. So, and later on in the term, we do actually a whole unit involving fractions. So I think what I'm going to do is I'm going to stick to just regular whole numbers now. And when we do our section on fractions, I'll come back and do equations that have fractions as well. Let's make sure we're comfortable with doing things that don't have fractions, because fractions make life more complicated. And therefore, let's make sure we're really solid on this before we go to fractions. But what we can do, do people have calculators? I'm going to show you how we could do a question that has decimals, because usually decimals are not as hard to work with as fractions. So let's do an example that has a decimals in it. Do you want to try it on your own first, and then I'll go through it with you?
No.
No, okay.
Yeah.
You know what? I'm going to give you a couple of minutes to try it on your own. I know, and those of you who are not comfortable, just don't do it. I'll go through the whole thing. But those people who want a little bit of a challenge, those people who know how to do this enough time, you're going to see when I do this problem, I'm really going to rely on my calculator. Even though I'm good with numbers and I'm good with, look at math is my thing. I always loved math, and not everybody loves math, but I still rely on my calculator. Now I happen to have a graphing calculator. As I said, you really should not be using a graphing calculator. The regular scientific calculators are easier to use and more appropriate for this course. And if you're going to need it for a science course, it's going to be perfectly appropriate. You don't want to have to spend over $100 on a calculator when a $10 to $20 calculator will suffice and be in many ways more helpful. But you'll see I'm going to use a calculator, but I'm going to use all my rules of regularly working with equations. So the first thing I see is that I have a parentheses, and I know I want to remove the parentheses. So in order to do this, I'm going to leave this alone, the 0.5x, and I'm going to multiply the parentheses. I'm going to distribute the negative 0.7 times with the 800 and the x. So on my calculator, I know I could do this in my head, but I'm going to use my calculator to multiply 0.7 times 800, because that's not such an easy thing to do in your head. That is giving me 560. And since this was a negative times a positive is going to give me a negative. I'm also going to have to multiply the negative 0.7 times the x, which of course will just give me negative 0.7x. And that is going to equal the 750 because there's nothing over there on that side to do. Now I'm going to look for like terms. And I do have like terms. I have a 0.5x and a negative 0.7x. Those are like terms, which means I have to combine 0.5, and I'm going to do this on my calculator. 0.5 minus, I'm going to subtract the 0.7. And that's coming out to be negative 0.2. So, and don't forget the x. In other words, when I'm putting it in my calculator, I just put in the coefficients, the numbers in front, but I let the calculator do the work for me. And I'm minusing the 560 because I haven't anything to combine it with, and that's going to equal my 750. And again, I remember my steps. I now have the x's all combined. Now I want to get all the numbers together, which means I have to bring this negative 560 to the other side. So I'm going to add 560 to both sides because this was negative, I'm doing positive. And since I know I could do this without the calculator, but I have my calculator. My calculator is, the point of a calculator is to make life simpler. So I'm going to do the 750 plus the 560 on my calculator, which gives me 1,310. Over here, I'm left with negative 0.2x. And again, like I did before, I have to divide by negative 0.2 because that's the coefficient. I have to do that on both sides. So I do the 1310 divided by the negative 0.2, and it comes out to be negative 6550.
No.
Let me see if any.
Yeah, I was very off.
Okay, do you see how to do it now?
Yes and no. Like I get
Yes.
the negative and positive thing.
Okay, do you see how I really used your calculator? Do you have a calculator?
Yeah, I'm using like the scientific one on my phone until the other one comes.
No, okay, hint. The worst calculator to use is the one that's on the phone.
Noted.
Not user friendly. And on top of that, you're really not supposed to have a phone when you're doing, let's say, a test or something. Now, it's very hard for me to take away your phone at this point. If you were in class, I probably would. But since you're not in class, really get a a calculator that's not attached to your phone. I have a calculator on my phone. I have it on my computer. I have to tell you, the best calculator, the one that you're going to be happiest with, is the one that you're going to go to Staples for, and either something like a TI 30X2 or something. Just look for something that says, doesn't have to be a TI, it could be a Casio, whatever. Again, in the $10 to $20 range, it shouldn't be more than that. Something that says 2-line scientific calculator.
So throughout this whole course, and even when we take tests, we're allowed to use a calculator.
Absolutely. And
Okay.
that's why I want you to get used to using that calculator right now,
Okay.
because you're going to see, I call it my best friend. It is my best friend. I use it. I'm telling you, I use it. Why should I spend time working out harder hard arithmetic when I have a calculator and I'm entitled to use that calculator? It's a time saver. Let's use it for what it's good for. I'm telling you that as a math teacher, I'm telling you that this is what I want you to do. It is not a crutch. It is a tool, and a tool that, truthfully, I often hear, I may take, but I use it when I go shopping now also. It just is. And you want one that's easy. You want something that's easy to use and makes sense to you. And I have to tell you, the ones on your phone are not. Okay, now let me just, I see in the chat, Jonathan, let me just check on my, let me take this Jonathan Martinez, I marked you absent. Jonathan, you hear me?
I'm here.
Were you here on Friday?
Yeah, that's correct. I wasn't here Friday, but I came
Oh, you were
today.
not. Okay, so I just wanted to keep track of it. Okay. And if you notice that you're not here when I'm taking attendance, just tell me sometime during class or by the end of class so that I make sure to give you credit for being here.
Okay, and I apologize for coming up late
Oh.
today. I apologize.
Things happen. Okay, so are we okay with this now?
Mhm.
Since we have about 25 minutes left of class, I just want to introduce the next topic. Again, I think at this point you look strong enough. Most people seem to be happy with it. In doing equations that have parentheses in them, even if they're decimals. Again, we're not going to do the equations with fractions until later in the term. We're going to do it before the midterm, but we're going to do it after we have a little bit more strength in just regular equations. Is everybody okay with that situation? Because if you want me, I can start with the fractions right now, but I know that once fractions hit, people panic a little bit. So let's really get this under our belt. So then when we understand, I wanted you to understand the topics. Then we'll get in, when we're working with fractions, what we're really working with is numbers and how to deal with numbers. And I'm going to show you how you could actually, I hope by then most of you will have calculators, and a nice scientific calculator, as I'm telling you, actually has fraction buttons on it. So a lot of your fraction work can be done with your calculator. So our next topic that we're going to be talking about is going to be inequality. And I'm just introducing it. in terms of, I want to introduce what the symbols look like and how it affects the look on the number line. There actually are 4 ways to write an inequality. There are 4 different types of inequalities we can write. I'm going to give you all 4 of them. Number 1, I could write something like x is less than 5. Now notice, when things are not equal, one thing has to be bigger than the other. Saying x is less than 5 means that the number you're talking about, the variable, is smaller than the number 5. We're comparing it to the number 5, x less than 5. A second inequality that we sometimes write is x. It's also a less than, but it says less than or equal to 5. This is read x is less than or equal to 5, which means that the number we're talking about, the x, the number we don't know, has to be either equal to 5 itself or smaller than 5. It's really telling you 2 things. Again, if you look at the symbol has a point at one end and it's open on the other end. Hint, the smaller, it always points to the smaller side. The point is always on the left side. So what are the other 2 inequalities we could write?
Could it be less than? I mean, greater than?
Right, x is greater than 5.
Or equal, greater than equal to?
Any number. That means that the number, this is saying x is greater than 5. In other words, any number bigger than 5 is included. Notice an inequality is not a single answer. It's a whole slew of answers. To say x is greater than 5, for example, means it could be 6
to infinity.
7, could be 2 billion. It even could be 5.0001. In other words, it doesn't even have to, it could be a fraction or a decimal also. Any number bigger than 5. And if you know that there is an infinite number of ways.
Professor, you said that the sign is always pointing to what?
The smaller one.
Okay.
So the open side is the bigger number. So in this case, it's saying x is the bigger number, the smaller number is 5. That's why it's called x greater than 5. And then, of course, we could have as our 4th one, x greater than or equal to 5. Now,
What?
when we talk about an inequality, when we talked about the answer to an equation, like we were doing before, if we got the answer -9, you could say x equals -9, but if you just said -9, that was perfect. You didn't have to put in the x equal, because there's only one way, it's only one way to put that. But when it comes to the answer for an inequality, not only must you put in the number, but you must put in the inequality. It's not enough to say 5 as an answer to an inequality. You'd either have to say x is less than 5 or x is greater than 5, because with any number, there are 4 different ways this could go. Now, one of the things that we do is we show what the inequality looks like on a number line. A number line is simply could be a horizontal line, in other words, one going from left to right. It could be a vertical line, but usually we make our number lines horizontally. We pick one number towards the middle and pull it to 0. And the numbers to the right, we just do spaces 1, 2, 3, 4, 5, 6, and go on, obviously all the way to the right. And it could go to the left, and those are the negative numbers, -1, -2, -3, -4, -5, etc. Now, let me ask you a question. This keeps going all the way to the left. What does it end in? What is the most left point?
Negative infinity?
Very good. The infinity sign looks like a sideways 8. Infinity means going on and on forever. You notice the 8 sign, or they don't put it, if you put it up, put it right side, it would be an 8, so we put it on its side. But it sort of shows you how it keeps going on and on and on and on. There's no end.
And this is for graphing purposes. That's where we're finding inequalities is for graphing purposes.
Actually, no, just to, we're not even going to, this is just going to be graphing on a single line. We're not, our next chapter will be regular graphing, but we're just doing.
This is just the number line, like with the filled in dot going left or right.
In order to see clearly, it sort of makes it clearer as to what it means that X is less than 5.
Sure, okay, thank you.
All the way to the right is what we call positive infinity. Now, infinity is not a specific place. When I say we're going to infinity, I just mean you're going on and on and on and on without end. It's not that you can say like 100 is a specific number. Infinity is not a specific number. It's just an indication that you're going on and on and on. Positive infinity means you're going on and on to the right. Negative infinity means you're going on and on to the left. Now, I'm going to illustrate each of these inequalities on the number line. I think it looks clearer when you look at it on the number line. Let me just. So let's talk about what does it mean that X is less than 5? Well, here's the number 5. I'm going to put a circle right at the number 5. And notice I'm not even filling in that circle because to say X is less than 5 doesn't include the 5. 5 is not less than 5. So 5 is not included. But let's say 4.99 would be included because that would be less than 5. So any number that's to the left of 5 would be X would be less than 5. And we would show that by making an open circle at 5 to show that the 5 is not included and an arrow going to the left. Now, because these are where on the left side are the numbers that are smaller than 5. Now, if you notice, this inequality sign actually looks like the arrowhead. And where is the arrow pointing? To the left. So therefore, our arrow has to point to the left. So as long as you have the X on the left side, and that's the correct way to write it, sometimes you'll come out, you're going to have a 5 greater than X, but that's not really the correct way to write an inequality. An inequality is always written starting with the X on the left side, your inequality sign, and then your number. If you have it written that way, the inequality sign looks like an arrowhead and it's pointing in the right direction. Now let's look at this one. Here again, it's a number line. Here's my 0. I'm not gonna make it so. Here's my 5 because that's the important thing. Of course, all the other numbers are written in, but I'm not. When I say X is less than or equal to 5,
It's filled in, right?
fill in the point at 5 because 5 is one of the answers and make my arrow from there going to the left. Again, this is an arrow pointing to the left, so my arrow has to point to the left. Notice what the arrow is showing you is where all the answers are. All the answers to this X is less than or equal to 5 go from the negative infinity, because this is pointing all the way to the end, all the way to here, but there's no arrow over here, so these are not part of the answers. Notice how many answers there are. Everybody okay so far? Okay, so let's look at the
Could
next.
you explain that again?
Sure. This says x is less than or equal to 5. That means you're starting, here's your 5, it's included in the answer, and anything, because this says x is less than 5, means anything to the left of it is also included. Any place I see this arrow means that that works for this inequality. There's not just one number that works for an inequality. If let's say this is a number -3 over here. And let's say this is a number 6 over here. Just look at this. Is the -3 included in the answer?
Yes.
Yes, because it's where we see the arrow. Is the number 6 included in the answer?
No.
No, because there's no arrow. So
Six
that's
and
what
five.
our number line is showing us. All the numbers where the arrow is are included in the answer. All the numbers where there's no arrow is not included. Now, if you look at the difference between the first one and the second one, the only difference was that here was an open circle and here was a closed circle, a filled-in circle. With the open circle, what it's indicating is that the 5 is not included. And with a closed circle, it means 5 is included. I'm going to show you, not today, but I'm going to show you another way this sometimes is written, because sometimes on a test, they write it a little bit differently. Is that clearer? Did that sound?
Yeah.
So now let's look at x greater than 5. So again, here's my number line, here's my 3, here's my 5. To say x is greater than 5 means that we're talking about numbers that are to the right of 5. Numbers like 6, 7, 8. Again, here I'm going to make an open circle because saying x is greater than 5 does not include the 5. 5 is not greater than 5. So we start with an open circle at 5 and an arrow going, did not do that too well, an arrow pointing to the right. Again, do you see how this looks like an arrowhead? Which way is it pointing? To the right. Notice it goes all the way to positive infinity.
And you said the open circle means what?
It means all the numbers that are bigger than 5, but not including 5. All the way to infinity. In other words, 100, 6, 25. But if a number 0 wouldn't work because 0 is not where the arrow is. And we know 0 is not greater than 5. Is that clear?
Yes.
Okay, so the last one, we have x greater than or equal to 5. In this case, we make a filled-in circle at 5 because the 5 is included, and my arrow going to the right because that's what this looks like, an arrow pointing to the right. So these are the 4 different inequalities and the way they could come out on the number line. Very often, we are asked not only to solve an inequality, but to graph it on a number line. And what we're going to have to be able to do is, once we have our answer, is to put the arrows going in the right directions. Remember, when there's no extra line here, which means there's no equal, we make an open circle. When we have this extra line, which includes this, we fill in this circle. That's the difference between like a less than or equal to, or a greater than or equal to, just the difference whether you fill in the circle or not. We're going to stop right here. If you did not get a chance to finish the examples that I had given you for homework for today. What I do with the Delta math is I give a late date. For each assignment, the late date is the end of the term. And you get 90% of your credit if you do the homework, even if it's late. So I really prefer, of course, that your homework is done on time, because when you do it timely, then you keep up with the class and you know exactly what's going on. But if you happen to do your homework late, you will still get credit for it. You will get 90% of the credit. You will not get full credit, but it's fine if you at least do. So I will allow you to do it late and still get most of the credit. Now, Melinda, I see you're here. Melinda? Melinda? Can you? I see her phone. I really would have, let's end this now.